This is for Year 12 methods. It comes out of Chapter 9, Derivatives, and really it's about how do I pick which rule to use? Do I use the chain rule? Do I use the product rule? And do I use the quotient rule? Okay, so how do you make the decision? It depends upon what's been presented. For product means multiply. So I can see here that I have an expression with an x and an expression with an x, and they're being multiplied. So u is going to equal e to the x and v is going to equal the sine of 2x. And because I have a 2 inside, there's a bit of a chain. I have an x in there, 2x squared, and I have a log base e of x, so they're being multiplied. So it's a product rule. I've got an x there and an x there. So this is u and this bit is v. Here I've got an x squared, so that's u, and I've got x in the middle of the sign, which is also squared, so that's a v. So they're all product rules and they multiply. These last ones, quotient, means division. So I've got an x in the numerator inside the logarithm and an x in the denominator cubed. Numerator, I've got an x which is inside a linear, and in the bottom I've got an x which is inside a quadratic. X on the top and x on the bottom, x on the top and x on the bottom, and x on the top and x on the bottom. So I'm going to make u the top, v the bottom, u the top, v the bottom, u the top, v the bottom, etc. And then I can use the rule, which is v u dash minus u v dash all over v squared. With all of these multiplies, it's u dash v plus v dash u. The chain is the trickier one because it looks a little bit more complicated. I can take the derivative of x, but I can't comfortably take the derivative of this, but I turn it into u to the half, where u equals the inside bit. I turn this into u to the half, where u equals 1 plus 3x. I turn this into the sine of u, where u equals 3x plus 2. I turn this into u to the negative 3, where u equals 1 minus x squared. I turn this into u to the negative 2, where u equals x squared plus 2x plus 1. And the same thing here, you turn this into u to the 2/3, where u equals 3x squared plus 2. So, if I have something raised to a power and I can use a rule to do that, then whatever is inside I make equal to u. What does it look like when I'm actually solving it? So let's do this last one here. Sorry, let's do this one here. du dx will equal 2 times 3 is 6x plus nothing. And dy du will equal 2/3 u to the negative 1/3. So dy dx equals dy du times du dx. Dy du is 2/3 u, which is 3x squared plus 2 to the negative 1/3, times du dx, which is 6x. And all of that's going to equal, the 6 cancels with the 3 to leave 2. 2 times 2 is 4. I've got an x, and over 2x squared plus 3x squared plus 2 to the positive 1/3 in the denominator. If I was to look at this particular question, let's look at that question. I'm going to make u equal to the bit on the inside. So u equals 3x plus 2. u du dx will equal 3. Y now equals the cos of u cubed, which means that dy dx will equal 3 times the cos of u squared times negative sine of u. Okay, so putting all of this together, dy dx will equal dy du, du dx. dy du is this here, which is negative 3 cos of u squared sine u times du dx, which is 3. So I've got negative 9 cos of u, and u is 3x plus 2 squared, sine of u, which is 3x plus 2. So the bit inside the bracket, the bit that isn't just x, make that equal to u. If my terms are multiplied, use the product rule. If I have a division, use the quotient rule. Now remember, we have little chains. I've got a chain in there, I've got a chain in there, I've got a chain in there, I've got a double chain in there, I've got the sign, I've got something squared, and inside my something I've got the sine of 3x. So there's a chain inside of a chain in that particular case.